my purpose today is to arm you with a weapon of science, an ancient, forgotten weapon used by the great physicists of old to give us the technological society we enjoy today. But first I'll review the problem that Henry has already told us about. Mainstream physics projects a world of floating abstractions, of space and time melting into one another, of quantum non-absolutes. And what this represents in my mind is an instrumentalist view of physics. Henry already covered this, a view that what's actually going on in the physical world, what's going on underneath the surface of the causes that of the phenomena that we see is not accessible to us, and it really doesn't matter as long as we're getting the right results. Shut up and calculate. What this represents is an abandonment of physics. It represents an abandonment of the identification of underlying causes. And this is a real tragedy. The primary power of science is to gain understanding of brand new phenomena, not just simply greater mathematical control over the phenomena that we already understand. That's, of course, very effective. But what gives us true new powers is the understanding of deeper phenomena. To understand the importance of this, imagine what would have happened to chemistry if the physicists the physicists and the chemists at the time had the attitude of today's mainstream physicists. If they did, the atomic theory of matter never would have been proven. They never would have taken it that seriously. Now, they still would have been aware of reaction ratios, the different kinds of chemical elements. These are things that can be measured directly. They'd be aware of these things. And what would they do? They would continue finding more and more complex and abstract mathematical models to identify the patterns that lie behind these chemical reactions. Now, of course, we know that the cause of these patterns is atoms and molecules, but that reality would have been forever hidden to them, if they had the same philosophy of physics as the mainstream physicists do. Now that gives us an opportunity. We are not content with floating abstractions. We know that these abstractions somehow have physical meaning, or we need to find the abstractions that do. We are the ones with the philosophy required to conquer the ether. So what's our plan? Well, it's the scientific method, right? Make a model, have that model make a prediction, go out into the field and test that prediction. If your model makes a prediction that the mainstream theory does not, then what? Are you then sure of your model? Well, I think we have seen that this method is a hard road. And it's a road that many of the great heroes of physics have died on, having made no real progress, no significant progress. Examples of this are David Bohm, Heinrich Lorentz, and Lajos Janissy. Bohm has a more rational view of quantum mechanics. It's not particle and wave at the same time, non-absolute. It's a wave that pushes a particle around, a completely reasonable hypothesis, but it doesn't make any new predictions. Similarly with Lajos Janissy, who's heard of Lajos Janissy? Oh, that's interesting. He has an ether theory of general relativity, and it makes all the same predictions as general relativity. So these great physicists were on this road, and they couldn't even produce novel predictions. Now, let's say that you do make a novel prediction, and actually it looks like we have a few novel predictions already. First of all, you're unlikely to get funded because by the very fact of you being outside the mainstream in our current way of funding science, you're basically labeled a crank just for being outside the mainstream. But even if the prediction happens, have you really proven anything? We are the first to know that a model can be wrong while still making correct predictions. Henry brought up the epicycle model, and we generally understand that the physics, the models we have today, general relativity and quantum mechanics, they make correct predictions, but they don't identify what's really going on underneath the surface. But we don't have to rely on this weak method. There is an alternative that was used to actually bring us this the great abundance that we have today. And I'm going to demonstrate that way with a simple example. Let's say that you rub a tube of glass and you find that it starts picking up paper. Once you observe this, you immediately know that this tube has a property that other objects don't. Now notice this, you didn't observe the property. It's not like the tube turned red all of a sudden. You observed the action. The thing you observed is the action, not the property, yet you know the property is there. How? The reason is because we understand that entities act in accordance with their nature. And if an entity commits an action that other entities don't, that means it has a nature or a property that other entities don't. As a result, you'll see that this scientist is able to come to a definite conclusion with high levels of confidence without guessing and checking, without using this standard hypothetico-deductive method that we were all taught in school. It is not a guess and check method, it is an observe and infer method. And this is the method that I believe we should use to conquer the ether. We all have great ideas. We need to reformulate those ideas into the method of inference, and this will give us real confidence. Let me continue with how that confidence is achieved. Let's look at another example, another simple example of how to use this. Let's say that, I need to go to this picture. So let's say that you notice that the cork inside your tube also became electric. So this gives you reason to believe that the electric property, that's the thing you decided to name this property, the electric property transfers from the glass tube into the cork. And so you think, well, maybe the electric property can move through objects. Let's test this. Now notice that the method of inference is not against hypotheses. It proves the hypotheses through a different method, and it's a method that actually allows for proof, as opposed to the guess and check method, which has given rise to the common notion that you can never prove anything in science. But let's talk more about how we could prove it. So you rig up this experiment. You take a glass rod that's been given the electric property, you touch it to the rope A. You touch it to the rope A. Is this the laser? Yeah, you touch it to the rope A. Then once you do, this glass ball B begins picking up little pieces of paper. It has gained the electric property. Now, you could frame this in terms of a guess and check. You can say, ha, that's what I thought would happen. But if you just say that, it doesn't prove anything. Instead, you can prove something by doing the same experiment, but simply reframing it in your mind. You can say this. We know that entities only act at their locations. That's the principle of locality. Entities do not act on one another at a distance. So we know that this glass tube had the ability to act on this rope. And this bit of rope had the ability to act on this next rope, which could have acted on the next, until this changed. Now, this only changed once you touched it. As a result of this inference, you know that you didn't just happen to get lucky. You know from inference that the electricity actually moved through the rope, through this rope, and into this ball. By reframing it, you suddenly gain a huge amount of confidence that you didn't have when you used the standard method we were all taught. And yeah, so I just said that. Now, what I've shown you so far are simple baby steps. But each of these steps gives us high levels of confidence and new understandings of things that we had no idea of before. And these baby steps culminate into a critical mass that gives us powerful control over the world. And so, for example, the modest examples that I showed you are the basis of our power grid. Because we can transport electricity through conductors, we are able to transport motion wherever we'd like at very little cost. Something that has saved us from enormous amounts of backbreaking labor and made enormous opportunity possible for everyone. Now, notice that this is not a guess and check method once again. It starts with observations. We make deductions from those observations, and that gives us knowledge that goes beyond the senses. Notice also that this method grants explicit knowledge of physical processes. The purpose of this conference is to reintroduce an interest in actual physical processes and their identities. This is the method to achieve that. This is the method that has given us the knowledge we have over physical processes that we have achieved thus far. It is a departure from this method that has gotten us to where we are now. There are other causes as well that Henry identified, but this is one of those primary causes. Now, notice that the hypothetico-deductive method, the HD method, naturally leads to a disinterest in ontology. The hypothetico-deductive method never allows you to gain certainty over your hypotheses. You just say, well, makes correct predictions, so I guess I'm going to keep believing it because that's the best I can do. But if that's really the best you can do, why be that interested about whether you really have the right model? Any model that reproduces the prediction, no matter how absurd, is as good as any other model. This is how we have accepted absurdities into our main belief system. The idea that light goes the same speed with respect to all observers. Why is such an absurdity accepted? It's not on its own merits, because they're absurd. It's on the fact that it makes correct predictions. And it doesn't matter how absurd the underlying theory is as long as it makes correct predictions, because that's the only standard on which to base anything. This is the method of inference. This alternative I'm presenting you is the method we need in order to stick to our conviction that we can identify underlying causes in reality. This method also achieves a higher level of confidence. Observations can be known with a very high level of confidence. Deduction from such observations, once they are done properly, once they are thoroughly checked to make sure they account for everything, yield a similarly high level of confidence. And these baby steps that I've shown you, not only do they lead to powerful applications, but they also lead to huge discoveries that culminate in integrations of lots of different pieces of data. Here's one more example. This is the experiment performed by James Prescott Joule, where he dropped a weight, this M over here. He calculated the work that the weight did. He knew that the work done by the weight would be transferred into this paddle. He knew that water was made of molecules, so he knew that the work produced by the weight would get transferred into the molecules. He then, once the stirring action calmed down, he measured the temperature, and he found that the change in temperature was proportional to the work put into the molecules. Now notice, once again, he could have framed this as a guess and check. He should have said, that's what I thought would happen. And that would have given him very little, but instead he can use the method of inference. He knows the work done by the weight went into the paddle. He knows that the work from the paddle went into the molecules. He knows that the amount of work was proportional to the change in temperature. He can now conclude, using inference, that heat is the motion of the molecules. Or at least heat is related. He has established this direct causal link between the two. Now, what I'm going to show you today is that this method is not just something that was effective in the past or some kind of floating abstraction. I can use it for you now to give us complete assurance in the existence of the ether. It's not after today's presentation, the ether for you is not just going to be a likely hypothesis that happens to tie everything together. It's going to be something that we know is there. In order to do that, let's analyze the physical meaning, the ontological meaning of the electromagnetic wave equation. To do that, let's look at a few locations inside of an electromagnetic wave. Let's look at these three locations that I've circled here. Now, notice that the electromagnetic wave equation is telling us that the electric field at any given location, let's focus on this location right here. The electric field at any location changes in proportion to the second derivative at that location. Now, what does a second derivative physically mean? I know y'all know what a second derivative is, right? Come on, but what does it physically mean? Who feels like, so you feel like you know what it physically means? No questions for now, but that's, okay, so yeah, let's go into it and you can tell me if you agree with this, interpretation. First of all, in order to understand that, let's talk about what the first derivative means. The first derivative of the electric field is the difference in the electric field between any location and a neighboring location. So here's the difference on the left, here's the difference on the right. All right, now, the second derivative is the difference in the difference. All right, of course. But what does that physically mean? Well, what that does is it takes this difference, it takes this difference on the right and subtracts it from this difference on the left, or subtracts this difference on the left. Now, let's understand what that physically means using some examples. This isn't easy to get. Let's say you have an example where the central object, this central location has a certain amount of electric field, and the neighboring locations have more. If that's the case, then the first derivative on the right is positive. Why? Because the delta x, I've added these signs to just show you what sign each thing is. If you move to the right, then the change in x is positive, and the change in e is positive. It goes up. When you move to the left, the change in x is negative, because we're going backwards, and the change in e is up. Now, we're subtracting a negative number here, and so this whole thing is going to be positive. Everyone on board? It's positive. So the second derivative is positive. As a result, the second time derivative will be positive. So what does that physically mean? It means that if the sides here have more electric field than the middle, the electric field at this location will increase accelerationally. The cause of the increase here is a difference here and here. Let's look at more examples. Let's say the two sides are less. Well, then that means this one is negative, and this derivative is positive, but we are subtracting a positive number, so the whole second derivative is negative. As a result, the second position derivative is negative, which means the second time derivative is negative. What do you think this indicates physically? Who thinks this, what would you say this indicates physically what's going on? Have I lost y'all?
Well, you said before that if the outer ones were stronger, it meant it was producing a force on the middle one.
It's causing a change on the middle one. Yeah.
In this case, there would be the opposite.
Yeah. There's more here than there are on the sides. And what the wave equation tells us is that this location is losing electric field. Now, the rest of my argument relies on this, so let's make sure everyone understands what my claim is here.
So
yeah.
It's losing electric field to the ones next to it.
Yeah. And the wave equation shows this. Yeah.
Like self-interaction.
There is no self-interaction here. This is getting acted on by the things on the side, and that's what the wave equation is showing us. This thing at the center is getting acted upon. This thingy at the middle is not acting on itself. Other questions to make sure y'all get this? Yeah.
Is this discrete? Oh, because you have...
Yeah, good question. I've implied that it's discrete, but, and of course, calculus doesn't treat it as discrete. It treats it as calculus does treat it as discrete. When you take a limit, even when you're using calculus, you're treating it as discrete. You're taking the limit as delta x goes to 0. Delta x isn't 0. It's getting as small as you'd like, which means it ain't 0. If it's 0, you've got a bunch of zeros on the bottom, and you're dividing by 0, which makes no sense. So yeah, okay. Yeah.
It resembles a social conformity experiment. You just look at your neighbors and you do
Yeah. We have intellectually dependent. We have intellectually dependent locations here. Okay. Are we feeling good about this? I feel an uneasiness in the crowd right now.
Go ahead.
Can I? Okay. Thank you. Okay, well, let's see if we can address that. One more example. In this example, we have a greater difference on the left, which is positive, and a lesser difference on the right, which is negative. Okay? As a result, we can look, when we look at the math, we can see this thing on the left. This is a negative number, but we're minusing a negative number, so this is positive. This whole thing's positive right here. And it is greater than this negative on the right. Can we see that? As a result, the electric field at this location will increase accelerationally. Okay, now why is that? Because the difference here causes this to increase. The difference here causes this to decrease. But this difference is greater, so overall it increases. Okay? Now, what this proves, if we analyze it carefully, is that there are entities at each of these locations. At each of these locations, we can see that there is a capacity for action. That's the field. What is a field? What's electric field? The only thing electric field means, if you look at the actual data, the only thing we know that it means for sure is that an action, a particular force, could happen at that location. So there's a capacity for action at this location. And secondly, that capacity for action can change based on what's going on nearby. In other words, this location contains an entity that can be acted upon. These locations can act, and they can act upon, and they can be acted upon. Therefore, anywhere the electromagnetic field exists, there is an entity. We can call this entity the electromagnetic ether. This is an example of the kind of method I'm trying to arm you with today. Now, you may have objections like, where did you get this concept of entity? My whole argument relies on this concept of an entity, so let me talk about that. Let me give more, let me flesh that out a little more. I'm not talking about a body or a substance. I'm not saying this entity is made of carbon or lithium or whatever chemical you care to name. I don't know what it's made out of. All I know is that it acts and it reacts in this particular way. That's all we know about it so far. That's all I've proven. But it's an entity. It acts and reacts. Now, the way we know that this concept of an entity is valid is because this is the concept of an entity that we've used our entire lives. And it's the concept of an entity that gave rise to all of our physical knowledge. And so, for example, you know that a person is an entity because they act on their surroundings. So, for example, you can see them because they're reflecting light into your eyeballs. They're acting on your eyeballs. But further, they can be acted upon. Here's Niels Bohr, who was an entity, and now he's getting hit by a tomato, which is what I wanted to do to him. In contrast, if you throw an entity at let's say you throw a tomato at a TV character, the TV character will continue as before. So we recognize that a TV character is not an entity. He acts at a particular location, but he cannot be acted upon. Your tomato will act on the screen, but the character will continue as before. If you throw a tomato at someone and it passes right through them, you're gonna entertain the idea that it's a hologram because it can't be acted upon. It's not a real entity. To deny that these objects that I have talked about are entities, you'd have to deny that other things are entities, that, you know, salt shakers are entities, and here's the important part. The way we're aware of electric fields to begin with is because of experiments we conducted on entities. We identified objects like, you know, glass tubes, pieces of paper. These are entities, and they acted on one another, and they were acted upon. And that's how, you know, you rubbed it, and now it became electric. So to deny these are entities, you'd have to deny basically the rest of science. I'm not reasoning from common sense here. I'm reasoning from fundamental principles that lie at the core of all scientific investigation. Scientific principles that lie at the core of everything you believe about science. The ether has now been proven, but we don't have to, objections to the idea that the ether has now been proven. Let's field those right now.
I got the big one.
You got yeah, you first.
Electromagnetism is really emergent phenomena, you know, and you can say it's like.
It comes really from quantum phenomena.
Yeah.
We're about to get there.
But when we are discussing
larger universe.
Yeah, then it applies. Here's the thing. This is an entity on that larger scale. I've proven that much. But I'm about to go into the Schrodinger equation. Henry.
Of course, the mainstream view is that fields and waves exist without a medium.
Ah, yeah.
And so they would say, we don't need a medium to explain
Yeah.
anything,
Yeah.
including this. Now,
Yeah. So the objection is that sure, there's an entity or there's something there physical, but it's the field. You don't need to talk about an entity or an ether, like it's just the field that's there.
Yeah, I actually philosophically define that as the fallacy of dropping the context.
Yes. This is forgetting that when you actually look for the evidence for fields, you will find that fields are just an action. They're an abstraction of action. They tell you what kind of action occurs at which location. And an action is an action of an entity. You can't just have actions floating around like, oh, hey, there's a heck of a lot of running in that room. Who's running? Nope. There's just a heck of the room's empty, but it's full of running. There's no one in there, but it's full of running. Doesn't make any sense. It's not just that it defies common sense. It defies the basic laws of existence.
It does.
Now, we can use this exact same line of reasoning to prove the existence of a gravitational ether. When you look at the gravitational wave equation, you see that there's this property h, and you can see that its second derivative of the property at any given, its second time derivative of that property, this is 16 different properties, the second time derivative of those properties at a certain location is determined by the second position derivative. In other words, there are entities nearby acting on the entity at the center, and that causes the entity at the center to change. So it's the same argument. There's a gravitational ether. The end. Now you might be wondering, like, why are you calling it a gravitational ether? An EM ether, like, isn't it just the ether? I haven't shown that yet. I haven't shown, remember, we're not applying common sense here. We're applying principles. You actually have to be rigorous. This method only works if you carefully check your logic and are extremely disciplined and constantly open to others finding cracks in your reasoning. If you are sloppy with your reasoning, this method is worthless. You have to be disciplined. And part of that discipline means that you do not accept anything that hasn't been proven yet. And further, we can go further and talk about the existence and then prove the existence of a matter ether. And we do this by examining the Schrodinger equation. In this case, we can see that there is some property, psi, and it changes over time in accordance with the nature of the property at neighboring locations. Same argument. Now you might be wondering, like, what the heck is this property? Is this even a real property? There's legitimate debate on this, and look, psi is somehow related to the probability of a detection event. It has something to do with a physical property. So it might be something very direct, it might be something very indirect, but it's some kind of physical property. So for example, let's say we had never seen an elephant, but we knew that some kind of creature was coming out in the night and crushing our cars. Well, then one property you could assign to this mystery creature is, how big of a car did it crush? Did it crush an SUV or a smart car? If it was able to crush an SUV, you know something about it. You know it was larger than a certain level. That's not very direct information, but it's still information. So no matter how indirect this property is, it's some kind of property of that location, and the property changes in accordance with the property at neighboring locations. Now you might be wondering, okay, cool, but the Schrodinger equation is a complex equation. Are you telling me that a complex number has real ontological significance? No. You don't have to write the Schrodinger equation out as a complex equation. If you make this transformation, you can say F's the real part, G's the imaginary part. If you just split it up like this, you can write the Schrodinger equation as two completely real differential equations. So the complex part is just a convenience of mathematics. It's not some deep ontological insight into like what the ether is. That's a red herring, I'm afraid. Credit to Travis Norson's book for that. Now, there's another really good argument, which is that psi is actually, in general, not a 3D function. It doesn't identify properties in three-dimensional space. It's in a 3n dimensional configuration space. If you have n particles, the friggin' function is 3n dimensions, 3n plus 1 for time. And so, like, what's the physical meaning of that? I can address that in the question period. It's kind of its own thing, so you can write that down if you want to know my answer. But for now, I can actually quickly overcome this by simply saying that my argument still holds for a single particle. You can see right now that the argument holds for a single particle. So what that means is there's a medium there, and it acts as a medium, the parts acting on each other. But in the n-particle state, the most that might be happening is that there's something else in addition to local action through a medium going on. And just because something else is going on doesn't wipe out the fact that this local action I have shown you is going on.
You have 30 minutes remaining.
Of the whole thing, or?
You're halfway through, and then to the Q&A mandatory part.
Right. Okay, cool. Yes. Okay. Now, and to refresh yourself on the argument, by the way, I've given you this piece of paper because it's key that you really get the argument. And so, many things will hinge on this. This next thing I'm going to show you is a fundamentally new argument to show that there is a duration-altering ether. Now, by the way, this is often called time dilation, but I refuse to believe time is this thing that actually stretches. It's durations. Certain processes take longer. That's what, so I refuse to call it time dilation. It's duration alteration. Now, to understand this inference, I want you to set special relativity aside. If you're accustomed to thinking in terms of special relativity, I'm not telling you have to agree with me and just wipe that out right now. I'm saying just set it aside. Look at the observations I'm giving you and just judge it on those merits. What can be inferred just from the observations in this experiment I'm going to show you? All right, so in this experiment, we have 3 vessels. We have a red spaceship, a green space station, and a blue spaceship, okay? On board each of these vessels is a particle accelerator. What they do is they create a radioactive isotope on board all of the ships. They then rig the isotope up to create to the proper circuitry to create an atomic clock. So they constructed an atomic clock. They actually made the isotope on board. And over the course of this whole experiment, each of the ships maintains their state of motion. So this one's moving to the right, the blue one's moving to the left, and the green one is stationary in the frame I've chosen. We let them proceed, and when the red ship comes across the same location as the green station, the red ship and the green station synchronize their clocks. Next, they proceed, and the blue ship and the red ship synchronize their clocks. So far, the time has gone from here to here. That we've measured this amount of change of the isotope as we went from here to here. Then we measured the change in the isotope as it went from here to here, and then we compared the clocks. If you do this experiment, again, forget about general or special relativity. Just look at the experiment. You're going to get more more decay happening on board this ship than you will on board this ship. So what does that show? That shows that when you do this, more change happened on board this ship than happened on board the blue and the red ships together. Okay? Now, what could have been the cause of this? What could have been the cause? Well, the only difference between these 3 vessels, these 3 isotopes, I should say, the only difference between these 3 isotopes was their state of motion. Okay? That's the only difference. So that's the only thing that could have caused the difference in duration of decay. Motion is always motion with respect to something. I skipped ahead. Motion is always motion with respect to something. Okay? Even if you believe in absolute space, when you say motion with respect to absolute space, you're still saying motion with respect to something. Okay? So if there's a difference in motion between these things, it's a difference in motion with respect to something, okay? Now, all action is local. An entity can only act on another entity that is at its same location. Therefore, the reason these objects are decaying faster or slower is because there is some entity along their path, some entity they're moving with respect to that is acting upon them to cause the difference in the rate of change. Therefore, anywhere you can do this equation, there is a medium, an ether that acts on these objects to cause them to change at different rates. And I have to credit my friend Dan Harris, who has a thought experiment very similar to this. Now, by the way, one other conclusion you can draw from this is something like Henry has noticed, which is that the only way to account for these changes is to choose some kind of privileged reference frame. But I've gone further here to say there's a privileged entity. Well, I don't know if it's privileged, but like I'm not even sure what that means, by the way. But there's an important entity at each of these locations causing the difference in change. Okay, questions on this? This is another linchpin of my presentation.
What's the difference between an entity and a privileged reference frame? What do you mean entity?
A privileged reference frame is just sort of like a geometric standard that you use to measure different motions. An entity is a physical thing that acts and can be acted upon.
So I guess.
Why do we need that? Because we're interested in describing the nature of the physical world, not simply modeling it mathematically. Jonathan.
Yeah, so with the setup of this thought experiment, I guess you're trying to avoid the issue of acceleration.
Yes, that's exactly why I had the atomic clocks built while they were in their current state of motion. Notice that not only is acceleration with respect to the ether, but I've proven that there's motion with respect to the ether also. The data we have already proves this. That motion with respect to the ether is, we don't know what the rest frame of the ether is, but we know there's something that we're moving with respect to. And when we move with respect to it, processes go at different rates. So it is something. Yeah.
That's the Einsteinian four-dimensional ether.
Okay.
You found.
We can discuss that. Yes.
I still don't see why we necessarily need a privileged entity or reference frame for this. So we could imagine this experiment from the rest frame of, say, the blue ship, and according to general relativity, the result should be the same, right?
Yes. We could perform this experiment from the reference frame of any ship, and we would still come to the following conclusion. The three vessels have different states of motion. That different state of motion is the only possible cause of their difference in decay rate. Therefore, it is some kind of difference in motion with respect to some kind of entity that causes the difference in the decay rate.
Right, but we can't infer the privileged reference frame alone from this thought experiment, right?
That we cannot, we can infer, again, I don't know what privileged reference frame means exactly. It depends on what privileges you're granting it.
Perhaps I can clarify, I think he's asking whether you can say that the ether is at rest with respect to one or the
Yeah. I know that's what you meant, but like so let me just be clear here. This proves that there's an ether that has some kind of rest frame. It doesn't prove what that rest frame is. I don't know how to do that yet. Yeah, that's right. All right, we feeling good about this? Cool. All right, let the ships continue flying. Yep. I believe a similar argument can be made for length contraction. I'll work on that some other time. Now, I've identified that we have these different ethers, right? We got these different ethers. I'm going to connect them now. The matter and the electromagnetic ether, the Schrodinger equation ether and the electromagnetic wave ether, these are the same ether, or they're at least related. How do we know this? Because of EM forces. Charged particles or maybe they're not particles, but charged entities, charged matter, acts on the ether. It produces electric fields and magnetic fields in them. Charged matter, oh, I've done it backwards. EM forces show that the ether acts on the electromagnetic ether acts on the matter ether. Charged matter is when it shows that matter acts on the electromagnetic ether. So we can see that these two ethers act on each other, or they're the same ether. Yeah?
You have a strong force ether?
I haven't thought about that yet, probably. I'd have to examine the strong force equations and yeah, I don't know. But probably. Yeah, but it's not proven. Very important distinction. Like just because I'm saying, yeah, I think probably, that's way different than what I've been focusing on today, which are proofs. The fact that you got particle creation and annihilation, you know, you can get a positron and an electron turning into a photon. That's another example of the matter ether acting on or being the very same as the electromagnetic ether. And I believe that if we focus more and do these kinds of inferential dissections of what's going on inside of a particle detector, a particle collider, there's going to be a ton of low-hanging fruit here. As just one man who's like developing this method or redeveloping it rather, I haven't looked at this stuff. So if you use it, there's going to be just a ton of low-hanging fruit for you to gobble up. I think, and particle colliders is one of the places to look. Further, we can show that the matter/EM ether is related to the gravitational ether, or it's the very same ether. How do we know? Gravitation bends light and matter waves, right? The gravitational ether acts on matter to put forces on it, and it acts on light to make it bend. So we can see that the gravitational ether acts on the EM/matter ether, or it's the very, or all three are the very same ether. Further, matter waves cause gravitation. So matter acts on the gravitational ether. The matter waves act on the gravitational ether. So again, that's another causal connection going the other way. Now, light waves probably cause gravitation, but we haven't directly observed that. That's just something that comes from Einstein's theories. So we'll see. I think it probably does, but not proven. Conclusions. There is an electromagnetic ether. There is a gravitational ether. There is a matter ether. All three of these are proven from the nature of the known wave equations. There is a duration dilating ether. And finally, I showed that they are all connected. What this shows is that the approach of people like Chantal and Donald here, it's not just a good idea. It's not just, oh, it happens to connect the dots. Something like what you guys are talking about has to be true. Some kind of integrated ether. Each of these phenomena being effects of the ether, and each of these phenomena affecting one another. Or they're all part of one big integrated ether, if that's the more likely hypothesis, because it involves less assumptions. But we don't want, but just because it's the most likely doesn't mean we just want to automatically assume there's one ether. Remember, you got to prove this stuff. Now, carrying on from here, like I said, there's fertile ground if we are willing to grab this weapon that has been offered to us by our intellectual forebears, then there are many more inferences we can make for ourselves. First of all, the Dirac and Klein-Gordon equations, we got to do an analysis like I just did on these. I just didn't have time. Further, we should do an analysis of the solution to the wave equation for the hydrogen atom. We should find out if we can specifically deduce length contraction and duration dilation from the nature of the wave equation. I've shown that duration dilation is somehow caused by motion with respect to the ether, but let's identify the actual mechanism. Now, I think you two have proposed mechanisms. I wonder if we reframe our investigation, not in terms of guess and check, but in terms of some kind of inference from what's already known. I wonder if we can prove one of your mechanisms, the specific mechanism. This might be one way to do it. this is just one suggestion. Did this in a certain sense. He showed that the force, if you say that the ether is moving, then the potentials are different, and gave a plausible argument that this would lead to the contraction of matter. But we want a completely rigorous argument, and that may not be too far away. So this is another place where we can make immediate progress. And remember, each baby step gives you another launch pad of certainty that can be used for further steps. Each step makes you more powerful until these baby steps accumulate into some big new discovery. I think that such deductions from the Schrödinger equation can also reproduce the perpendicular Doppler effect. Basically, the idea is the emission and absorption lines for atoms change when they're moving. And so why is that? It's probably because of the alteration of some kind of internal process inside. Let's understand the nature of that internal process and why it is changed, why specifically the mechanism for why it is changed when we do motion through the ether. Notice how now at the end of the presentation, I'm able to talk with confidence about motion through the ether. It's not a hypothesis anymore. That's an example of the power each baby step gives you, because now you can launch harder off of that next stone that's rock solid under your foot, not just like, oh, well, shit, maybe I can go forward, but it's all just, supposition. No, it's each step, maybe small steps, but confident steps. And as I alluded to earlier, you can use this method to reframe your existing work. So for Donald, something now, I still need to read your book, but something that occurred to me is let's see if we can deduce wave collapse from the known nature of the vacuum oscillations. Have you already done that?
Well, maybe after tomorrow.
Let's see. Yeah, let's see. Maybe it's something really close and we can reframe it or something.
Course,
Yeah.
Work, science never ends.
Science never ends, but you do get answers. Once you get answers, the next question avails itself.
Okay.
Yeah. And then for Chantal, Chantal has all these great models. One suggestion is to strip those models of their analogies and hypotheses. This concept of stripping, I don't have a lot of time to go into it, but basically what you do is you take your hypotheses, and if you strip them of all of the analogies and all of the things you're not sure of, first of all, analogies are good because so Chantal's analogy is that of an elastic solid. The parts of the ether seem to act on each other in a way that is analogous to the way that the parts of an elastic solid act on one another. But that is just an analogy. The ether probably is not literally an elastic solid. And Chantal has always agreed with that. And how do we know that? Well, it's because solids are matter, and matter's a wave of the ether, as I just showed, so it can't be like a solid that's waving to create the solid. That makes no sense. It needs to be a new kind of entity underneath. And so what you do is this method of stripping. You take your hypotheses and strip them of all the elements you're unsure of. Whatever remains is something that you are sure of, that the prior observations and inferences make you confident in. And deductions from that solid ground gives you further solid ground to walk on. It's more baby steps to reach the jackpot.
About 7 minutes remaining.
Okay. Let's see. I have to go a little faster then. Yeah. And bring your questions to me for how to do this. I want to empower all of you with this method so that you can use this to make confident steps. It's going to get a little bit annoying probably sometimes because I'm probably going to tell you some stuff that is just a hypothesis. They say, no. But remember, if we strip away the things that we're unsure of, we can now walk confidently on what remains. And what is required here is a change in mindset. You're going to have to retrain yourself to search for inferences, not for guess and checks. But this is, I can tell you, this is hard for me to think of still, because I was trained in the same schooling that you were about the guess and check method. This is going to have to be a self-improvement goal to change the way you think, you frame these questions. Note that I'm not against the guess and check method. It still falsifies things, and that's useful. So I'm not saying throw it in the trash. I'm just saying it's weak. Focus on this. This is what's going to give us much more power and certitude. By the way, you'll notice that you already think like this all the time. Sometimes you're using inferences all the time. What I'm telling you to do is to do it as a matter of principle and to do it with a thought out method. So I've painted a dismal picture with the hypothetico-deductive path of guess, check, and you end up with an uncertain conclusion. The path of inference, instead, is to get clear on what observations and reasoning are proven so far. Remember, you have to get clear on that. You make inferences proving new aspects of nature. And enough of these baby steps make larger and larger steps. And I believe that our end goal should be the discovery of some new phenomena and some new application. We should not be begging mainstream physics to accept our ideas. We should make progress and make mainstream physics obsolete. This will be a very hard task, but I think nothing less than this will be required to achieve our goals. So what are the next steps? As I said, get clear on what you know for sure and what is just a hypothesis. Reduce your models that you have already made to what is already known for sure. And look for the low-hanging fruit. Remember, these are the baby steps that cause exponential progress. Look for the inference that you can make just based on what you can do once you get clear on what's known. Then devise observations or use existing data to make further inferences. Inference is not just about contemplating things on its own. You have to go out and look for new data, of course, to get that final little puzzle piece that makes the inference come together. And when we reach a critical mass, this will reach a brand new application. This should be our goal. And now I turn it over to questions.
Yeah.
Alexander, yeah.
Yeah, thank you very much. I have two questions. I'm a big fan of the ether, by the way. So,
A big fan of what?
don't be worried. I have two questions.
Okay.
First, there is this book, which looked at the history of electricity, ether and electricity.
Uh-huh.
And he points out a lot of different versions of the ether, like McCulloch's incompressible ether. Maybe you could establish some link to these historical examples so people can understand that. That's the first question.
I think these historical examples, if you look, they were all of limited success. From my survey, I may be missing something, but from my brief survey, I think they were of limited success, except for Maxwell's model. I think maybe you could argue that these were all on the right track and they made Maxwell's model possible, because Maxwell's whole formalism was based on an ether, but it was an analogy. It was a bunch of balls pushing on each other and spinning and frictionally rotating, and he knew that wasn't what the ether's actual nature was. So he rightly stripped it to a theory of just fields. He wasn't trying to say you should look at the fields and that's it, and then just stop there. He was just saying that's all he was certain of, and that's true. He didn't have my argument, so he didn't know there was an ether for sure. At least I haven't seen him make my argument. I don't think you're 100% sure of the ether until you see this argument. I'm not saying I'm the first I know of to prove it. So I think the history of these models has limited success because they were always analogies. And they tried to model it, and then they didn't try to they didn't strip it of the hypotheses and analogies, and they didn't try to make inferences from there. It was just a model, and that's of limited use if you don't pair it with this method. Other questions before we return to you? Just so we have one at a time. Yes?
More a comment than a question. You kind of restored my hope in my own sanity. I'm a molecular biologist.
Nice.
For 80% of the time, molecular biology, and in fact mostly biology, works in the way you described at the start. We make observations and then we start, what is this observation what do I see? What can I do with it? What is the mechanism which can happen? Oh, I have a bacteria which produces citric acid. How does it do that? Is it some kind of entity there which probably may be a protein? In fact, blood clotting factors are, back when they were discovered, people didn't really understand proteins. We didn't have modern molecular biology. And you can see in the names of these are just factor X, factor 11, factor A, factor B, because we didn't know what they physically are. We just knew that there were some entities. This entity does that, this entity does that, and they interact somehow.
Yeah, and this was understood, yeah.
And we still do that. And when I started to interact more with physicists during my postdoc in France, I was confused.
Yeah. Yeah, biology is much healthier. So the questioner for the mic, the questioner is...
Biology is also still in poor shape. But this has...
Biology is what?
Is also in poor shape. And,
okay.
Chemists are also. So the problems in academia are not just this one problem.
That's correct. That's correct.
Also the which should be maybe careful.
Yeah, I did not want to make the impression that this is like the mother of all problems. This is really just one of the major ones, but more importantly, this is one of the big solutions. We should focus on the positive, not just be against mainstream physics, but have a positive vision for how to get past the limitations and really make new discoveries. Excellent. Other questions? Alexander.
Yeah. You said that the historical models were not successful.
Okay.
I think the misconception was, or the lack of imagination was, that they imagined the particles as an external substance, whereas you can defects in the ether, topological defects are kind of this.
Yeah, well, yeah. Sorry. Yeah.
And these kind of defects have shown to be relativistic in the sense that draw a close analogy, the speed of light being the transverse speed of sound, and as Frank, I think it was in 1949, has pointed out, you get all the relativistic mass increase, the length contraction, and that was the thing what blew my mind and said, oh wow, we find relativity in here. Was that part of your motivation too to deal with
Yes. Yeah, and it's worth noting. And it's worth noting that Maxwell's successful model treats the particles as a defect in the ether. Yeah, that's worth noting. Yeah, they do. He does. Other questions? Yeah.
For density, as in Einstein's mind, he thinks that I think that the four-dimensional ether is so that there is a light, rays, and net of them, but no three-dimensional ether any other than normal matter. But I found so that the four density has the contribution for three-dimensional density, but it's fuzzy. It's not just like normal matter. It's fuzzy, and I think it's tangent for your ideas.
Okay. I'd have to look more into that, but my only comment would be that direct observation shows us that time is not a dimension like space. Time is a measurement that indicates an interval of change, and it's fundamentally different from spatial relationships. Jonathan.
Yeah, so I just want to mention there's this quote from Popper in 1906, where he suggests, based on these kind of considerations, that matter would be nothing but holes in the ether. Yeah, and I also wanted to make a remark, because both of you guys were pushing about this kind of realism about entities and so on, and pushing back against the tendencies that you see in modern physics, which sort of were rooted to some extent in Maths philosophy and then the popularity that gained with Einstein and so on. And I think there's room, like I agree with you on the issue of causation. Mm-hmm. You need to find causes of things. Mm-hmm. But there's room for some kind of like so-called anti-realist critique from time to time when you're in between paradigms, right? So when you're very familiar with, like I'm familiar with these kinds of objects around me, and I can say my laptop is an object and so on, and it moves as a solid and so on. But if I'm encountering something I'm not very familiar with yet, it works, and that's why you were talking about, how Maxwell didn't commit to a particular interpretation of this theory. When you're not exactly sure how it works, you need to be ontologically kind of like
yes.
You don't want to commit too much to one particular interpretation, and that's where this kind of like Machian critique of realist takes in science can be quite useful. And I think Poincaré in particular has a very nice take on how to think of these things.
Okay, I'll summarize for the mic. You're saying when we start entering new territories, when we start making discoveries about new phenomena, we have to remain open to different fundamental rules of ontology. So, for example, perhaps when we discover when we discover some new phenomena, we may be open to the idea that entities do not lie at the core of the causes of what we're seeing. And I would say, yes, you do need to be open to that, but there are no instances in the past of phenomena being caused by something other than entities. All of our experience thus far has had entities at its root. And so, as a result, the probability of something having non-entities at its root are extremely small after this much experience. But still possible, but it would require very specific evidence that something fundamentally new is happening here. You would need that before entertaining such a notion.
I mean, an example of this is simply if you have an ether conception of matter, if you're thinking of matter as waves in an ether, then your ontology kind of shifts.
Oh, you have to change what you mean by an entity, because now a wave is an entity.
And so
yes,
that's all I mean is,
and I've done that.
Is you have to be prepared to change where you're drawing the boundaries between objects.
Yes, absolutely. So Jonathan's saying, if you start thinking about an ether, you have to start drawing the boundaries between entities differently, and you start having to think of maybe waves as an entity. And I strongly agree with that. So actually what's here is, what I've shown you today is part of my theory of induction. I have a whole book identifying a scientific method, and this is a very important part of that. And so PDFs of my theory of induction are available to anyone here for free. I usually sell it on my website, but it's for free. Anyone, just come to me and I'll send you a copy. Part of my theory of induction is a theory of broad physical categories, which are empirically derived definitions for entities, actions, causes, and these fundamental categories that we're reasoning from in order to make these inferences. And these categories are drawn from experience. So if new experiences arise, you do have to update the categories. And one example of this is my concept of a formal entity. A formal entity is something that has its properties as a result of its structure, not its material. So for example, man is a formal entity. After 8 years, all of your matter, all of the particular atoms you're made out of get like sloughed off or flushed down the toilet, to put it crudely. And so what is you? It's not the material, it's the consistent process of action. It's the consistent relationships between those materials. And in like form, a wave is like that. As a wave moves, some entities are being shown into the wave to participate in that waving action, and then other entities are being shown out, just like in a person. So, so that's the concept of a formal entity. You need to form things like this to make it all make sense.
There is a question there. Is it between form all the way down?
There is no evidence for that because we've never seen form without matter. Yeah.
Okay, well, we can talk.
Yeah, these are good. Let's keep going with this. Other questions I got?
It's about 12:10, 12:15. We got break.
Okay, yeah, so like 5 more minutes and then I'll make my closing statement. Henry.
Well, I would, in my talk, I emphasized how this restriction of knowledge to experience and measurements and so forth was a negative. But I would agree with Jonathan. I do agree that modern science arose from this kind of empiricism because they needed to escape Aristotelian categories and forms and actions and so forth. And Francis Bacon and others criticized Aristotle quite a bit. So indeed, at times when we don't know what we're doing, sticking to the observations is a very good idea.
Yes.
Until we have a better theory of what's
the fundamental categories of Aristotle or Bacon or me or anyone have to be consistent with the observations, not the other way around. Other questions and comments? Yeah.
I see the duration you draw is the part of entity, correct?
Duration is a characteristic of a process of change.
which includes change within entities.
Which includes change within entities and the change of the relationship of entities to one another. So motion is a process of change. I'm changing my spatial position with respect to you right now and to everything else in the universe. So that's a process of change. And then as I digest, that's a process of change. But that process is, I think it amounts to a bunch of movements of individual atoms inside my stomach.
Just you found the second derivative, then you have the issue with the infinitesimal moments.
We start wrapping it up, Jim.
Oh, one more question, then my closing statement? Yeah. Okay, one more question. And we can keep going with this discussion later. I'll just close now then. Now, I think that the opportunity history has given us is more than just an opportunity in physics. I think this is an opportunity to show the entire world what is possible. You see, people once looked to Newton's method of science and his mechanical view of the universe for guidance, for inspiration. His method of science showed people that the world is knowable by mankind, that we can have immense success in knowing the world and mastering it. And his mechanical view of the universe showed us that the entities of the universe act according to particular natures, that once those natures are known, we can use them to our advantage. But that is no longer the case. The world projected by mainstream physics is an irrational one, a world where space and time melt into one another. This painting was literally inspired by the theory of relativity. It's a world where quantum abstractions allegedly prove to us that there is no objective truth. And without this guidance, is it any wonder why politics is irrational? Now, we may have differing opinions on what makes politics irrational and where that irrationality lies, but I think what we can all agree is that the debate the debate is full of irrationality and lies and evasion of the truth. But here's something to think about. Why be rational when physics isn't even rational, when the core of existence is irrational, when that's what the experts tell them? Why be truthful when quantum mechanics shows us that there is no truth to be loyal to? So I think that the juncture we have come to here is an enormous opportunity. An opportunity to show the world that we do not live in a non-absolute world of floating abstractions, but we live in a rational, knowable universe that is ours to command and to explore. Thank you.